Hi YouTube, Tim Eckert here. In this video we're going through an Algebra 2 quiz review on geometric sequences. So let's get started. Question 1, write the recursive and explicit definition for the following geometric sequence. So we have first term is 2, then 6, 18, 54, and so on. Alright, so the recursive definition has two parts, and I'm just going to abbreviate that as RD. So we have to have the first term, we'll call that a sub 1, and that is 2. And then we have the nth term, a sub n, is going to equal the term before it, a sub n minus 1, and we're going to multiply that by the common ratio r. So to find the common ratio r, you take any term and divide it by the term before it. So I could take the second term, 6, and divide by the first term, 2. Or the third term, 18, divided by the second term, 6, and so on. If I divide 6 by 2, I'll get 3. So we're going to multiply it by 3. And that's for when n is greater than 1. All right, I'm also going to do the explicit definition. Okay, and that gives us the nth term. We'll call that a sub n. We take the first term, which is 2. First term 2, and we multiply it by the common ratio 3. And we raise that to the n minus 1 power. And that's for when n is greater than or equal to 1. All right. Problem 2. We're going to find the missing term in the following geometric sequence. So we've got 50, a missing term, then 12.5. And we can do that via calculating the geometric mean. And we can either put the geometric mean or its opposite. So to find the geometric mean, we're going to take the square root of the product of the two terms surrounding the missing term. So we're going to do 50 times 12.5. We'll do the square root of that. And we can put that into Desmos. So let's open up a tab, go to Desmos, and we'll do the square root. Put in here, square root of 50 times 12.5, and that gives us 25. So the missing term could be 25, or if the common ratio is negative, it could also be negative 25. So either of those two values will work. All right, problem 3. Find the common ratio of the following geometric sequence. We have 300, 100, 100 divided by 3, and so on. So to find the common ratio, we take one term and divide it by the term before it. So I'm going to do the second term divided by the first term, so 100 divided by 300. And I'm going to leave that as a simplified fraction as 1/3. So there we go for that one. All right, problem 4. Use the explicit definition of the following geometric sequence to find the 11th term. Here's the geometric sequence. So we have 2, negative 10, 50, negative 250. So we need to know the first term, which is 2. And to know that with a sub 1, we need to know the common ratio. So I can take negative 10 and divide by 2. That's negative 5. And n, the number of term that we're looking for, is going to be 11. So the explicit definition, let's write that first. That's going to be a sub n equals the first term 2 times the common ratio negative 5. I'm going to put that in parentheses. We don't want the negative out front, but we want it in parentheses. That's going to be raised to the n minus 1 power for n is greater than or equal to 1. All right, so the 11th term, a sub 11, is going to equal 2 times negative 5 to the 11 minus 1 power. So that's going to equal 2 times negative 5 to the 10th power, which is going to be, so we'll do 2 times negative 5 to the 10th power, which is going to be 19,531,250. So that's my solution to that one. Let's keep going. Problem 5. Find the two potential missing terms of the following geometric sequence by finding the geometric mean and its opposite. So we're going to take the product of the two terms surrounding the missing term and take the square root of that. So we do 3 times 1/3. Take the square root of that, which is going to be the square root of 1. So the geometric mean is 1. So it could be 1, or it could be the opposite of 1, negative 1. All right, problem 6. Write the explicit and recursive definitions of the following geometric sequence. All right, let's start with the explicit definition first. All right, so, well, we're going to say a sub n equals the first term 10. We've got to figure out the common ratio, so to do that, we'll do negative 20. Let me fix that, negative 20. Negative 20 divided by 10. So the common ratio is negative 2. So we're going to multiply by negative 2 to the n minus 1 power. I'm going to get rid of this stuff, make some room. And that's for n is greater than or equal to 1. Okay, for the recursive definition, we need the first term, so there's two parts. The first term, which is 10, and then how to find the nth term, we'll say a sub n equals, we take the term before it, a sub n minus 1, and we multiply it by negative 2, and that's for when n is greater than 1. Fix that greater than sign. All right, problem 7. Find the common ratio of the following geometric sequence. All right, so the easiest two terms are the second and the first term, so I'm going to divide the second by the first. I can simplify this fraction and leave it as 1/4, or I could do 0.25. So it's best to leave it as a fraction like 1/3 when it's a non-terminating decimal. But if it's a terminating decimal, you can leave it as a decimal. All right, problem 8. Find the 13th term of the following geometric sequence. So we want to, first up, come up with our explicit definition. It's going to be a sub n equals our first term, negative 2. We're going to multiply by the common ratio. So the common ratio r, we do negative 8 divided by negative 2, we get 4 for a common ratio. So times 4 to the n minus 1 power for when n is greater than or equal to 1. Okay, so the 13th term is going to be, we're going to do negative 2 times 4 to the 13 minus 1 power. So negative 2 times 4 to the 12th power. All right, so Desmos. So we'll do negative 2 times 4 to the 12th power, and we'll get negative, let's see, negative 33,554,432. So let's see, 554,000. I think it was 432. Yep. And there you go. And that's it. Hopefully you found this video helpful. If you did, please like and subscribe.